Extra question 5. A recent study found that 80% of all MBA students intend to start their own business at some time in the future. A random sample of 20 MBA students is taken, and then we have several probabilities to calculate. Now, as soon as we know we're dealing with a probability question, we need to think about what type of probability question it is. And certainly the fact that we've got one fixed probability as well as a sample of a certain number of students. So we've got a fixed probability, we're repeating something for each of the students, we're asking them whether they intend to start their own business. Well, that certainly does suggest to me that this is a binomial situation. We know it's discrete when we're talking about students. We can't have half a student, so there's going to be a discrete outcome in terms of our sample of 20 students. When we start saying, well, how many of them intend to start their own business, it's going to be a discrete number. And we have that fixed probability. So it does tend to suggest that this is binomial. We can run through those characteristics and just check for that. And we would always do that first for any discrete probability situation, because if it is binomial, that's going to save us a bit of time in terms of we can go straight to the tables to get our probabilities for the calculations. So for binomial, we've got to have a situation where the underlying experiment has only two outcomes. Here we could say, well, they either intend to start their own business or they don't. So sort of to answer the question, we ask each student, do you intend to start your own business? The answer would be yes or no. Two outcomes. Do we repeat that n times? Well, yes, we're going to ask 20 students. So for the first student, we either get a yes or a no. Second student, yes or no. We've got that underlying experiment of two outcomes. We're repeating 20 times. Do we have a fixed probability of success? Well, yes, if we declare a success to be an answer of yes, they intend to start their own business, we know that the odds of that happening are 80%. So we've got our fixed probability, and is each trial independent? Well, if I ask the second MBA student, what the first student said will have no influence on what the second student said. So we've got independent trials, we've got all the characteristics for a binomial situation. This is binomial. Now, don't forget that when you establish that a situation is binomial, you must make sure you've identified n and p. So n, our number of trials, in this case, is the number of students that we survey, 20. Our fixed probability of success, p, is 0.8. So 80% as a decimal, 0.8. And we've declared a success to be starting their own business. So that's our sort of success or yes answer. So we've got n, we've got p. We can go to our tables, and here I've just got that table replicated from some Excel output. You'd look at your printed sheets. You go to n equals 20, and you'll see that your x's, your outcomes, go from 0 to 20. You then find the corresponding column for a fixed probability of 0.8, and you can see we've highlighted that here. It's column L in our spreadsheet. So you've got all those individual probabilities, and now we can answer the question. Now, part A, what's the probability that at least 11 intend starting their own business? So at least 11, what are we talking about? We're talking about 11 or 12, 13, all the way up to the maximum, which is, of course, 20. So we could write that down. You can write it down as x greater than 10. You could write it down as x greater or equal to 11. They're equivalent. And of course we know because the tables only give us the equals probability, we must break down that probability that we want into equals components. So we need to get x equal to 11, x equal to 12, all the way up to 20. So start for the 11th row, add up all your values down to the last row in that column, and you should end up with an answer of 0.997. So there is a 99.7% chance that at least 11 of our 20 student sample intend to start their own business. Part B, similar technique, but again, just be very careful when you're reading through the word problem. We're looking for the probability that between 12 and 18 inclusive intend starting their own business. between 12 and 18. What does the inclusive mean? It tells us that we want to include 12 and we want to include 18. So when we write it down, we could say we're looking for x greater than 11 but less than 19. We could say we're looking for x greater or equal to 12 and less than or equal to 18. Either way is fine, that's the same thing. However you write it down initially, you've then got to look at all of the individual components, because again, that's all the tables give us. So we need to add up the probability that x is equal to 12, x is equal to 13, all the way up to x is equal to 18. So again, move down through the rows of that column and add up the values that need to be included. You should end up with 0.921. Part C, exactly 16 intend starting their own business. We're looking for the probability that x is equal to 16. This is probably the simplest of all three calculations. And equals probability, you can just go straight to that row within the table, read across for an x of 16. We see that the corresponding probability is 0.218. So a 21.8% probability of that happening.